So today we're joined by Alex Crane, who's an enterprise architect, and Brian Chambers, who's a chief architect, both at Chick-fil-A. Alex likes camping and cooking in all forms and gets way too excited about platforming things. And Brian is, outside of work, he loves travel and adventure and active stuff like CrossFit, hiking, mountain biking, climbing, and mountaineering. Did I get those backwards? No, we good?
Pretty good. You got it right.
Okay, I think we got it. Okay. So we can get started. I'll get off the mic again. If you've got any questions, please come to the front. I think that's going to be the best. And then I'll throw a mic at you if I have to. Otherwise, I can hand you a mic. Let's
Awesome. All right. Well, hey, everyone. We are honored that you are here to close down Datadog Dash in the afternoon on the last day. So thanks for everyone who stuck around to be part of the session. We're looking forward to it. So we're going to talk a bit about observability at the edge, and we'll tell you what that means. But as we mentioned, I'm Brian Chambers, Chief Architect at Chick-fil-A. I've been there for about 19 years. This is Alex.
Alex Crane, Enterprise Architect at Chick-fil-A. Been rattling around there for about 4 years on staff. So,
yeah. Awesome. And Alex does love to platform everything. So we're going to talk, like I said, about observability. And so just to give you a sense of what's in store for you in our agenda, we're going to kind of set the stage, first of all, talking about what do we mean when we say edge. Not sure if everybody's familiar with the idea of edge compute or not. So we'll kind of lay the land for that. We'll talk a bit about why Chick-fil-A did that, and that all kind of sets the stage for why does observability even matter in this case in the first place. And that's really the goal, is to spend the rest of the time unpacking a bit about the architecture that we use so that we can observe this fleet of 2,800 Kubernetes clusters that you can see mentioned here on the slide. And then hopefully lots of good questions from you guys about what, why, how, et cetera. So that's the goal. So in case you happen to not know Chick-fil-A, we are a quick service restaurant. We've got about 2,800, probably closer to 3,000 at this point in the year, restaurants in the United States primarily, a few here and there in Canada. We're also in Puerto Rico now, which is cool, and then opening in some other places soon internationally. Those restaurants are run by 2,000 independent owner-operators who employ about 300,000 team members. And Chick-fil-A is kind of known for like quality and service, and then of course also for being closed on Sunday. But even given that, we're actually like the most busy quick service restaurant, per footprint, per store, in the United States. So a little bit about the business, just so you kind of know where we're coming from. So question number one, really, what is edge computing? And so let's talk about that. So I like the definition of edge, which is edge computing is really about putting your workload, your app, your thing you want to do, as close to the user as is necessary, not possible, necessary, but no closer. And there's a lot of different kinds of edge. So we start thinking from the cloud, and just to be fully clear, we didn't do any of the stuff that we're going to talk about because it was cool or fun, even though it is and was. Our goal was really solving business problems, but our default is if it can run in the cloud and meet its objectives, let's do that. That's less constraints, much more capability, much easier to run and operate. So that's the goal. But then there's certain times where, because of the performance you want, because of the business continuity you want, et cetera, it makes sense to run a workload somewhere else. And so edge is really about moving across that spectrum towards your user, even in some cases all the way to the device maybe that's in their back pocket. But in our case, when we talk about edge, we're talking about compute that exists at our place where business happens, which is in our 2,800 restaurants. So to tell you a little bit about why we would do something crazy like that, here's a little bit of context about what happens in Chick-fil-A's business. And I won't read all these stats for you. You can kind of read them off the slide. But the point here is every one of our Chick-fil-A restaurant footprints is like super busy. Who here has ever been to a Chick-fil-A through a drive-through, et cetera? Show of hands. Engagement here in the afternoon. All right. Some of you guys haven't. Okay. Surprising. Awesome. Well, you should check one out when you get the chance. Come see me. I have limited coupons for afterwards. But that'll give you incentive to stay till the end. But our business is really, really busy, and that has driven us to deal with a lot of growth problems and capacity constraints. And we're an organization that believes that one of the key things that we can do to help each of those businesses continue to be able to grow while maintaining good customer experiences and great food quality is by employing technology. And so one of the first things that we started looking at as we started to face these capacity challenges is how do we get better really visibility and observability to our business, to what's happening there. How do we start to collect more data about the things in the environment, which led us into IoT, Internet of Things. We started connecting things primarily in the kitchen to start, fryers, grills, holding cabinets, refrigerators, et cetera. And so there was kind of like a little bit of a question at the beginning of like, what do you do when you want to get all that stuff? Like, should you make those things smart? Should they have intelligence? Should you send them data? And I remember a story where somebody mentioned wanting to send all of our real-time transactions in a stream into a fryer, and it was like, I don't think that's going to work really well. So the alternative pattern that made a lot more sense in our minds was, let's make those things kind of dumb but connected. Let's make it possible for them to send out telemetry about themselves. Could be things like the temperature of a fryer or a grill. It starts a cooking cycle. It ends a cooking cycle. Things like that can be useful to us to understand what's happening in the business. So we started to collect that stuff, but we wanted to be able to build applications on top of that data that could do things in the real world, like display what a team member needs to do in a much more targeted way that makes their job easier, or move towards automating certain processes in the restaurant. And so that led us to this journey of edge compute. And our solution, you guys may have seen this picture before, but ended up being something that looks like this. Kind of gives you a sense of the scale. Our physical infrastructure is about the size of a Chick-fil-A sandwich. We have space constraints in addition to others. But essentially what we wanted to do is run containerized applications, because that's how our teams are used to building in the cloud, and we wanted to mirror that as much as we could at the edge as well. So we are enabling teams to build containerized apps that can basically interact with all of this different IoT and other data that's flowing around the restaurant, things from the kitchen, things from the point of sale, et cetera, and ultimately build better experiences for customers, for the restaurant owner-operators, and their team members. And just to give you a sense of what's involved in our stack, it ends up being these 3 Intel NUCs, which were sadly discontinued by Intel recently, but picked up by Asus, so that's cool. But we've got the NUCs, and then we run a version of Kubernetes called K8s. On top of that, you may be asking yourself, why is a chicken restaurant running Kubernetes in all of their locations? Isn't that overkill? Isn't that ridiculous? We've been asked this many times. It's yes and no. It's a hard feat to do, but it made sense for us. And it goes back to, we had containerized workloads. We want to run them in restaurants, and we really wanted business continuity, in addition to helping with our capacity problems. So if our internet connections to our stores go down for some reason, we want to be able to keep operating and not really remove the force multiplying impact that these applications that we're putting in the restaurants have. So that led us to needing something to orchestrate all of these workloads, to schedule them across nodes when there's hardware failures or software failures or whatever. And that led us to pick Kubernetes along with like the rich open source ecosystem that was developing at the time. And actually one of the tools that we'll talk about in the second half of the presentation is an open source version of a tool that works great in Kubernetes. So that is what we mean when we say edge, and that's a little bit about why we did it. Oh, wrong button. All right. So in terms of what we've built, just want to give you a sense of kind of the topology of the organization. So everything I've talked about so far is the edge platform. So think of it maybe like a cloud platform. It's a team that is building the base infrastructure, the physical compute, the operating system, all those things, up through that Kubernetes layer that we just talked about, and then a series of shared services that sit on top of it for things like messaging from IoT devices to a broker, that's MQTT, authentication, deployment services, databases, et cetera. So all that stuff in red, that effectively represents what the platform team owns. But it doesn't really stop there, because the goal was to enable other teams to be able to build out different kinds of business applications on top of these services that can do things in the real world, make great experiences for people, right? And so this is just context for the second part of the presentation, but that platform team has certain preferences and certain things that they do. They actually use Grafana as their primary tool to observe what's going on. Some of our other teams use different tools. They may use CloudWatch and Amazon. We're a big Amazon shop, or they may use Datadog or whatever. So we're fairly high degree of autonomy for teams to pick tools out of the toolbox. We don't mandate that everybody use the same thing, but we want to enable people to build, deploy apps, and then be able to observe those ultimately inside of the store so that they can operate them, support them, et cetera. And then last, before I hand it off to Alex, the edge is really interesting because there are a lot of constraints. The cloud, we've gotten really used to what feels like infinite scale and all kinds of capability and great network, and we just don't experience many issues with those types of things. An edge environment, especially in a restaurant environment where things are like in an office and people are unplugging it to plug in their cell phone, that type of environment has a lot more constraints. And so when we talk about observability, these are a couple of the ones that are pretty key that factored into the way that we thought about our solution. So logging, for example, we have a lot of different teams deploying apps, and if those teams are just kind of spewing out debug logs in some crazy amount, they potentially produce something that we really can't scale. We can't store them all, we can't egress them all, et cetera. And that kind of ties straight into number 2, which is bandwidth. We have limited bandwidth. We have pretty decent connections to most of our restaurants in today's world, but unfortunately, it's still not enough. We've actually had some great stories in the early days of building this solution where log egress actually consumed all the bandwidth for the store, and we could no longer process credit card transactions for customers. So not awesome. So we've fixed some of those things with the solution that we're going to talk about, but that's another constraint that we have to deal with. Another is cost. If you think about the 3,000 times n, whatever your different metric cardinality is, it can potentially be really big and really cost prohibitive in a lot of solutions. So that's a challenge and something we had to navigate as well. And then finally, what I call heterogeneous origins, meaning not everybody in our environment is doing the same thing or even is the same class of thing. So we've got, like, if you think about the previous slide, the things in red, those platform apps, they work a certain way, and they tend to have like kind of a first-class metric mindset, which we'll talk about in a moment. But then you've got our teams that are building apps on top of our platform. They may take a little bit different approach to doing things. And then we've also got our IoT devices, like the fryers and grills that exist in that environment. And they're doing things like sending out system logs to an endpoint we provide. So we've got all these different kinds of originators of telemetry data, operational data, that's necessary to achieve observability of a restaurant. And we had to factor all that in while managing all these constraints in the process. So I'll hand it off to Alex to talk a bit about the solution and how we've solved for observability in the store.
Awesome. All right. So I'm actually going to skip ahead to that one right there. So I'll kind of start off with what's a metric, right? So there's a few types of metrics. I believe most of y'all here know what metrics are in general, but I think there's some different behaviors and quantities, et cetera, that you get between system metrics, application metrics, business metrics. So system metrics, most of us know and have worked with for years and years, where CPU, memory, et cetera, right? And actually, when we talk about the quantity of metrics, most tools, most agents, you go to enable them to scrape metrics, right? And you end up with like 73 different memory metrics related to your memory, high memory, low memory, memory pressure, yesterday's memory. Then similar for CPU, et cetera. And you don't care about most of those, right? Do you have alerts set up on all of those? Are you watching for all of those? Can you even look at all those on a dashboard? Similar application metrics, that's kind of been around forever, but it's really something that people have paid a lot more attention to, the closer you get to today in history of web requests, the actual, like, from in-app metrics, how many times you're writing to the database in your app, the quantity of errors per minute, not just getting that from the logs. And then business metrics. This is the one that I find very interesting for being able to look for issues that may be going on. If you think about, to use sales as an example, somebody may have pushed a new app, may have pushed a new feature, but sales, if you're just charting errors, et cetera, nothing's throwing an error. It's just swallowing the sales amount or not multiplying it by something it's supposed to. And so you've seen this change. Well, you haven't, because you didn't have business metrics right next to your application metrics. So I think business metrics are another very interesting one to be tracking there. So a couple different types of metrics. Trying to sneak back. There we go. First-class metrics versus log-derived metrics. So with that tee-up of kind of what metrics are, one thing particularly for the edge that we found is a huge benefit in what I call first-class metrics over log-derived metrics, right? So log-derived metrics, a lot of people are familiar with. You have your logs, you're sending them in somewhere, and you're creating the metrics on the fly by having the tool, by having Datadog query those metrics and present them. It's very flexible, right? As long as you were logging the whole wide world, that was very flexible. You could look for things you didn't think to bake into those first-class metrics in your app. And that's useful, helpful for things you weren't looking for ahead of time. Now, first-class metrics, way cheaper to send to the cloud, right? When you think about what's getting what's getting sent, right? It's only sending that number, that change over that window to the cloud. It's not a whole log line. All right, so that brings in what is vector and where are we using it? So if if you go to Vector site, vector.dev, it's an open source tool from Datadog. Vector enables you to collect, transform, and route all your logs and metrics with a single tool. So what does that mean? If y'all have used FluentBit or other tools, FluentBit's a log forwarder, Vector is a log forwarder and a metric forwarder and a trace forwarder. But more than that, you can filter your logs, you can filter your metrics, you can aggregate metrics right there before they go on to the next hop. And where that's useful for us in restaurant is we may have apps that were instrumented at really low intervals for exporting those metrics. Or you have a dev who left debug on, or is like they've got a Java app that's running and it's got like these giant stack traces just woo. We can't be sending that to the store or to the cloud from the store, just unfettered. So Vector is really cool in that, so not only can it aggregate those metrics from the pods, those metrics from IoT devices getting sent at the cluster, turn logs into metrics, and then go to the cloud. So even though an app or something that might be more off the shelf that you don't have control over baking metrics into, Vector, you take those, do that right there and send it to the cloud. So you're not having to eat that bandwidth and doing that later in the cloud. So lots of good use there. The other thing is the fan in and fan out. So, and we'll show that in a second here, so we've got apps in the cluster pointed at Vector, or Vector scraping those for both the logs and the metrics. IoT devices pushing their logs and metrics over TCP to the Vector in the cluster. And we're able to fan those in so that we can send those to the cloud as one. If you have the apps and you have the IoT devices going directly at the cloud, sometimes they misbehave, right? And they just start going nuts sending to the cloud. And actually the example that Brian mentioned a little bit ago with the logs taking over and stopping the credit card processing, there was an issue where we were getting dropped packets on the network at the store. So the tool we were using at the time was going ham, trying to send that same 50 mega logs over and over again. It'd get into, drop packet, let's start over. And it just sat there. And so one device, took down the store internet with that. And so by piping that stuff through kind of one central point, we can put limits on that to both, if we're in a restricted data scenario, like we're on fallback internet, we can allow priority stuff through with rules and not the lower priority stuff. So another cool trick that we have is not sending all the logs up, but we gave our devs the ability to hit an API endpoint to request the logs for certain apps and applications that we don't stream all the time, so they can get that log pack and go pick it up in S3 or have it delivered into Datadog for them. But then that way, just all those logs that you're not looking at and might never look at, we have them there for retention, but they can get it as needed if they do need to go deeper.
Just to add to that, the default for all of the applications that get sent to the stores is to only be logging in error mode, so there's no debug. But what we enabled on the back end of that API is basically just GitOps, some config that goes through a GitOps pipeline that can tell a store to turn on for like 30 minutes debug mode. And then we start getting that full flow of logs, which is probably justified if somebody's troubleshooting an issue that's happening that they can't reproduce otherwise, and so they need that. But it auto shuts back off, so we don't end up with this problem of, over time, everybody's left their stuff in debug, and we're back to, a crazy onslaught of data on the cloud side. So,
absolutely. All right, so now those lines go up to the cloud, and what happens there? So one thing, as an enterprise that we've run into is the fact that not all our teams use the same tool, and not all our teams actually can use the same tool. And in fact, some of our vendors, we don't have control over what tool they use, and it'd be handy for them to get some of those metrics or logs for their tool or their product that's in our restaurant. So as those logs hit the cloud, we fan back out with Vector. We define rules in there, and based off those rules, we have metrics go to Datadog, and metrics and logs go to Datadog for one team, CloudWatch for another, Grafana for another, and Splunk or whatever tool, S3 bucket that a vendor needs. And also, this isn't just a pure split. Some of this stuff goes to multiple places, right? Sometimes you get two groups who care about the same metrics. But it allows everyone to kind of get the most value of that and not force everyone into a particular tool. And everyone gets the real-time nature of their tools out of it, right? Otherwise, we'd be trying to export data from one of these to give to somebody to load into another tool elsewhere, and they'd always be very latent. So what's next? Got any ideas?
No, not really.
I don't remember what next slide is.
Where are we going next?
Yeah, where are we going next? Do what? Yeah, circles. Yeah, I don't know. Yeah, where we're going next, I think it's interesting. I think a lot of stuff's changing and moving in the space. I think even what you saw there, the diagram is kind of reduced is reduced for conveying the information simplicity. But I think for me, it's about, is there a way we can simplify this further without compromising on a lot of the things for why we got there, right? Without opening up to risk of unfettered data transfer, et cetera, that can be blocking it up. I definitely feel the complexity that we've picked up in our tech stack over a number of years. This solution has worked very well, but as we move forward, definitely want to see what we can't do to reduce the complexity of the stack.
Yeah, I think what we really like overall about the solution is that we enabled part of our model for delivering software, which is teams have a high degree of autonomy. In certain cases, it really makes sense to platform things, and something like a restaurant environment, what we desperately did not want was a bunch of teams rolling their own hardware stack and network stack and everything stack to solve problems, and then everything's a silo. There's no interoperability in restaurant. Observability of actually the business things becomes a challenge. So we really like that, and we're really committed to maintaining things like that, having platforms that can be force multipliers, hopefully make it a lot easier for people to get things into restaurants than if they had to roll their own. But I think we continue to iterate on how do we best do that, and what are the things that are emerging, what are the patterns and tools that are emerging that can keep making this stuff easier and ultimately help us with those capacity, observability, scale type challenges.
How do we pack generative AI into the edge? It'll do that for us.
That's right. Awesome. So we said we'd stick to 20 minutes, and I think we're right around there. So this is where you can find us if you're interested in connecting after the fact. We're going to have time for questions here in just a moment. But
How come I got numbers after mine?
I think you didn't get on LinkedIn early enough, or you didn't change your profile. I have dominated the Brian Chambers brand, I think, on LinkedIn, so you should be able to find me, but Alex has got work to do, I think. So, and then Chick-fil-A also has a tech blog. We write a lot about the things that we're doing there. There's quite a bit about the edge, but we also talk about other things we do on the cloud side, other business problems we're solving. So love to have you check that out if you're interested.
Thank you so much. Let's give a huge round of applause to Chick-fil-A.
Thank you, guys.
Thank you.